viewers, welcome back. Today we will be concentrating on merge sort. Before we get into the video, let me remind you, if you like our channel, please like it. If you have not yet subscribed, please do subscribe so that when we add future videos, you'll be intimated. And if you really like it, you can share with your friends also. Okay, let's get into merge sort. This merge sort comes under the technique which is called as the divide and conquer. Let me briefly tell you what is this divide and conquer. So we have a bigger problem. Since the problem size is very big, it is quite difficult for us to solve the problem. So what we do is we divide the biggest problem into smaller sub problems. These sub problems are further solved and solution are being obtained, and when all the solutions are obtained, they are being merged together or they are being combined together to get the solution for the original problem. So a big problem is divided into small problems, and each small problem is being solved and later combined to get the solution for the bigger original problem. So that is the concept behind divide and conquer. Having the same principle, we have this merge sort working. So this merge sort is nothing but a sorting technique for sorting the numbers. Okay. So what is happening here? We have a list, or like we have an array of many numbers. This big array is going to be divided into smaller groups, and later each smaller group is going to be solved, and the solution for each small group is being combined or merged together to get the solution of on a whole for the larger problem. So let us look into the problem with an example as well as with the algorithm for dividing as well as merging. So we have two parts here, that is divide and conquer. In the case of this divide and conquer merge sort, we have the division taking place, then the merging taking place. So we call the division part, this algorithm, as the merge sort algorithm, whereas the combination, the combining part, the conquering part, the merge part is the merge sort algorithm. Okay, let me tell you what this how this works and then explain the algorithm for you. Now we have a set of 8 elements. So this is a bigger problem of how many elements? 8 elements. So you have 1, 2, 3, 4, 5, 6, 7, 8. So according to our concept, it is going to be divided into 2 halves. So how are we going to divide into 2 halves? Normal formula, the original one is the number divided by 2. So it is going to be 4. So 4 elements, 1, 2, 3, 4, which will be taken as one set. The remaining 4 will be taken as the other set. Okay. So now what happens? These elements become the sub-problem 1. This part becomes the sub-problem 2. So now this is also a bigger set which can be subdivided into smaller. So how many elements are here? 1, 2, 3, 4. So 4 divided by 2 is going to be 2. So 2 elements each we are going to divide. So this will be a subproblem and these 2 numbers will be another subproblem. So here 2 elements are there. So 2 divided by 2 is going to be 1. So we have 8 and 3. So this is how the division has taken place. So now let me show you the algorithm and explain to you. So here we have an array called from 0 to n minus 1. So 0 position 1, 2, 3, 4, 5, 6, 7. So this is supposed to be n minus 1, 8 minus 1. Okay. So here we have the array A, which has all these elements in an array. So we check whether this n is greater than 1. So is 8 greater than 1? Yes, of course. So we can get into the problem. So now we have to copy this array set which is there into two divisions, that is B and C. So what are we going to do is we have to copy this element 0 to n by 2 minus 1. So n by 2 is 4 minus 1, the third element. So 0, 1, 2, 3 elements are going to be copied to this array which is going to be B array. Okay, and now what is going to happen in the next step? Then the next part of it, that is from n minus 2, 4, which is here. Okay, this n minus 2 to n by 2 to n minus 1 are going to be copied to another array which is going to be called by the name C. Okay, hope you have understood that we have the bigger array set which is being divided into two halves, and one half is being copied to array B, another half is being copied to array C. So what happens next is, it is going to be a recursive process. Recursive process in the sense, it is going to repeat the same process again, as this is going to be the input and it's going to divide further. Let's try it out here. So now here what happens, these are the newly set array. Okay, so now you have 4 elements and they are being placed as 0, 1, 2, 3, where this is n minus 1. So what is our first thing? We have to divide this particular big array set into two halves, that is 2 elements each, or we have to have it. So here this one is going to be B1 array and this one is going to be B2 array. So which are the elements which are going to go there? So we have 0 to n by 2 minus 1 is going to be 1. Okay, according to this formula which is going to be copied here. So 0 and first element are going to be copied inside this set, whereas the remaining, that is 2 to n minus 1, that is 4 minus 1, 3. 2 and 3 are going to be copied inside B2. So this is how it happens recursively. Similarly, when this is being called, what happens? It's the same set which is going to contain 7, 1, 5 and 4, which are to be divided into two halves with 0 and 1 in one set and 2 and 3 in another set. So 7 and 1 will be copied here, 5 and 4 will be copied. So this is not the smallest unit. So here again we just go for further division. So 7 will be put here, 1 will be put here, 5, 4. Similarly, this will also get finished. So this is the role of merge sort, that is, it is dividing the bigger array set into the smallest sub problem. The big problem with 8 elements are being broken down into 8 different sub problems. So now let us get into the next sort. So this is the next sorting technique, where it is being called here. After we finish sorting, then we have to merge everything. So merging B, C with A. Okay, that is the principle. So we are calling for the sub problems into the bigger set on which we have to put all the elements. So let's look into how we are going to put this. So now each sub problem is going to have elements of smaller size, and they are going to be combined, and it's finally going to be a combinatory factor, that is p q minus 1. Let me tell you what does that mean. So here you have 8 and 3. How do we normally solve? We will just compare 8 and 3, which is smaller. So obviously we know that 3 is a smaller and 8 is a bigger number. So combining these two, we find that this is in a sorted order. When we compare these two elements, 2 and 9, what happens? 2 is supposed to be the smallest number, then 9 is going to be the bigger number. Then comparing these two problems which are being combined, what are we going to do? We will take the first element here, compare with the first element of this particular set. So what happens? We find 2 is the smallest element. So we have added to the new array. Now comparing this element with this element, we find that 3 is the next smallest element. So we add to the array. Now moving on to the next element. Now this is compared with 9. So 8 and 9, 8 is the smaller element. So now which is being left out is 9. So we add this 9 here. This is the principle. But how do we how do we know that this, what size is it? So to determine the size, we have the combinatory factor. Okay, let me tell you. So now this is how we go initialize it. That is, we have this size as I and this as j, which we are going to compare and we are going to do. And this is going to be k. Okay, so when we do operation with these three, it's going to be I, j and k. So this will be represented by B, C, and this is going to be our A. So what is going to happen is, we check out whether this I is lesser than this P. Okay, that is, we find out like what is the size of it. So it's 0, 0, 0 is location. So we find out whether it is okay, whether the element is present or not. Then what do? We compare these two, B of I and C of I. So if we find that B of I smaller, then what do? We add that element into the array. But since in this condition it fails, what happens? It goes to the next box and says that this is the smallest element and it adds the value into the array A. Then what happens here is, this value j is being incremented by 1 and the value of k, which is here in 0, gets incremented to the next position so that the next element has to be added. So now you find that all the elements are being emptied in the C block. Only B1 element is available. So we transfer this all the remaining elements which are there into the array set. So here similarly, comparing these two, we find 2 is going to be smaller. So we add, and this doesn't have any other element further, and all the elements in C are being added here. So now these two sub problems which are being sorted, what happens now? This first element is being compared with the first element. That's what happened. We have solved. Okay, let me do it afresh for you here so that it will be easier for you. So now 7, which is going to be the B side, and 1 on the C side, and we are going to add it in the A. So what is happening here is, we have 7 and 1. Comparing these two, we have 1 as the smaller number. And after this, what happens? We don't have any other element left in C array. So all the elements which are being left in the B are being copied in the A array. So here similarly 4 is the smallest. Since nothing is there remaining, so we have everything added here. So now on the whole, like now we have two different subproblems with many different items here. So what happens? 1 is compared with 4. So obviously we know 1 is the smallest element. So here the next position it is being transferred to. So now 7 is compared with 4. We know 4 is the smallest number. So 4 is being added. Then 7 is compared with 5. So we know 5 is being added. So we don't have any other element. So the left out element which is being there is being added to this particular array. So now we have an array set which is slightly bigger in size. Like it's been merged or combined. They are being conquered together so that the solution are being updated. But still we have not got the solution for the original problem. So now we have to get into. Now you might be wondering what is the 0, p minus 1 and 0, q minus 1 and everything. Let me tell you, now you have 4 different elements. 4 elements here, 4 elements here. And you have to be, like you have the positioning being done like this. So this element that is taken as p and this is taken as q. So now when you look into the position, so you have it from 0 ranging to p minus 1. So you have p as 4, so p minus 1 is going to be 3. So here this C array, it ranges from 0 to q minus 1. Now we have to know like how many blocks or like how much of space has to be put. So now what we have to do is, we don't know like how much do we need. So we use that formula as P plus Q minus 1. So what is P here? 4. What is Q here? 4 minus 1. 8 minus 1. So 7 is going to be the last position. So here you have 0, 1, 2, 3, 4, 5, 6 and 7. So you have 8 elements. So they are being positioned like this, 0 to 7. Okay, now let us combine those and let's look into. This is how we allocate the space, and now let us go for comparison. Now 2 is being taken as the first element compared with this first element. So we know 1 is the smaller number. And now 2 compared with 4, we know 2 is the smallest element. Then now this gets implemented. So 3 is compared with 4, we find that 3 is the smallest. So again it gets implemented here. So we find 8 and 4, 4 is the smallest number. Now comparing 8 with 5, we find that 5 is the smallest number. Then 8 with 7, we find that 7 is the smallest number. Now every element in C are being added to this list. So we don't have any comparison to be done with 8 and 9. So what do? We pour out the content of the B array to whatever space which is being left out in the A array. So 8 and 9 are being added to this. So here what we find is we have got a bigger set for which we have to sort and get the answer. From here we have divided into sub-problem, and here we got it as the smallest unit. From this smallest unit we started combining with each other, that is merging, and finally the final set as an answer for the original problem we have got. So since the bigger set is being subdivided into smaller unit, we have a complexity of n case of let's sort. Because the bigger problem is being subdivided into smaller problem, and we can solve the problem easily, and this is being done recursively too. Okay, hope you have understood what is divide and conquer method and how it is being put in this merge sort, and how the algorithm works, and how do we go about by placing it and interpreting number and going them and replacing for the value and sorting and how we go about that getting the solution for a bigger problem. Okay, so hope you enjoyed learning merge sort with us. If you like our video, please like it. If you have not subscribed it, please do subscribe for future videos. If you really like and if you want to share with your friends, please do. But don't forget to share with your friends. Happy learning. Have a great day.